just go ahead and do one all the way down. Take 4 or 5 minutes, whatever that takes. Shouldn't take any longer than that. And then have everything written out, and then I'll do it real quick. Okay? So, I want to do a good one that maybe you haven't seen before. If I do ones that you've seen before are super similar, then they're not as challenging or not as interesting to do. So, let me get one here that I find that could, we'll do that one. Okay, so go ahead and do that one. We'll eventually get into doing some more ICE problems, ICE problems. They don't show it with ICE, but I find it really much easier to use the ICE. Most everybody did that in here when we did those problems. So why don't you go ahead and solve that one, and then we'll give the answer to it. You balance it. The iron chromate, the iron-free chromate is the solid. Then everything that's aqueous, you split apart. Spectator ions are potassium and chlorine. So then what you're left with is chromate ions and iron plus 3. So then to balance it out, it'd just be 3 chromate ions for every 2 iron ions give you the solid. Okay? Okay, anybody want to do another one? I mean, we have a little bit of time, so we want to do another one. How about we do another one based upon a problem that we're going to do? We're not really going to use the complete ionic or the net ionic in the problem, but we'll go ahead and show it anyway. Okay?
Okay.
So let's have you turn. We're going to do a problem that when we form precipitates, that is something that's a solid, and it's something that we can predict how much solid's made. And so we're going to look at the bottom of page 138. And there's a problem there. I'm going to go ahead and write it out because I'm recording this, but I'm going to go ahead and write it out. And what I want you to do is I want you to go ahead and write everything, the whole reaction out. So I'm going to go ahead and write it out, and you guys go ahead and write out the 3 parts like you were doing, like we did that one there. So just go ahead and write the formula equation, which is without charges, and then go ahead and write the complete ionic. That's showing all the charges of everything except for the solid that's being formed. And then go ahead and write the net ionic, which is taking out the spectator ions. So when Ag and Cl get together, that's the solid. When Na gets with NO3, that's aqueous. Now, I know you guys have the complete ionic, but I want to show you something that may help you out, because in the future, I might just have you write the net ionic for the whole equation instead of everything. So, all you have to do in the future, okay, and we'll practice a few more of these later on, is these are both spectator ions right there. The Na and the NO3, they're both spectator ions, right? Mm-hmm. So what I can do, I don't even have to maybe show the complete ionic, because I know which ones are going to cancel out. I know this one's going to cancel out, and I know this is going to cancel out. So what no, I'm sorry. Reverse that. I know the Na would cancel out, not the chlorine, because the chlorine's part of the solid. So, I know the Na would cancel out, but the chlorine won't cancel out. Okay? So those two cancel out, guess what you're left with? Cl minus and Ag plus. And so that's what's down here, skipping that step. I'll show that middle step, but if you notice, I can kind of maybe skip that step in the future because I'm seeing things a little bit more clearly after I've done a couple of these. And I know the solid is the only thing I need to show in the net ionic. And if I notice that the Na and the NO3 cancel, those two are spectator ions. I'm left with chlorine and silver ions. But if you guys wrote everything out, you'd have the Na plus, chlorine minus, Ag plus, nitrate minus, the AgCl. Well, there she is. We're just doing a little bit of precipitate reaction.
There you go.
Yeah. How's things going?
It's going.
Did you guys get that?
Mm-hmm.
Okay. Do you guys see what I mean by, you can maybe skip that middle part?
Yeah.
Okay. Because some of you guys see it really well. You see, on the other side, if you see it's aqueous on the other side, those ions are really the spectator ions you can take out. So, just for your information. So, let's look at the problem. All right? Let's just look at the problem and see what it says and see what we need to do. What did they give you? And then what are they asking you for? So, I'm going to go ahead and copy this and erase some of it. Okay. And erase. Yes. Get rid of that all. So, now you have it below you, and you might have to rewrite. You might have to rewrite a portion of it again, but I'm going to leave that up to you, how you want to do it. So, we have our NaCl, and we have it reacting. So I'm just going to write out the formula equation. And Ag3. I probably should have erased it, but I had lines messed up through it and that. So I'll go ahead and get a clean copy of it. You guys will really like these problems now because they're going to be really similar to what you did when you did the stoichiometry, because that's what this is. It's just kind of repetitive stoichiometry. Okay. So you guys remember the ice? The initial, the change, and the ending amounts. All right. So you guys have already did these problems. What we need to do is we need to find the moles of AgNO3. Okay, so they're asking us what's the mass of NaCl that is required to react with all of these ions that are silver ions. Okay? So, what I want you to do is I want you to take this information and find the moles of AgNO3. So what I want you to do, guys, remember molarity. This is moles, which would be, molarity is moles over liters. So you did problems on an assignment about maybe a little less than a week ago. And you had to figure out moles and grams and volumes and that with a molarity equation. So go ahead and find the moles of AgNO3. Yep. Okay, so we have 0.15 moles. How do you do that? Well, I have it set up right here. 1.5 liters. And then what you can do is you can just times that by 0.1 over liters. Liters cancel out. You'll end up with moles. You'll be doing a lot of this. So you will be doing a ton of where you're finding the moles of something from its volume and from its concentration. So we got 0.15 moles of that. The initial amount of NaCl we've got to find. So this is not a limiting. This is just a way. So question is, it's a 1-to-1 ratio. How many moles do we need of NaCl to react with all of the 0.15 of the AgNO3? How many moles? 0.15. Did everybody see it's 0.15?
Yeah.
Okay? It's the same. 1-to-1. So it has to be the same. Now if this was a 2 here, okay, so if this, let's say if it was a 2, I'm not saying it's a 2, but let's say if that was a 2, then how many NaCl's would I need? 0.30, right? If that was a 3, then I need 0.45. Okay, but it's not. Let's say this was a 2 in front of that. I mean, it's not. I'm just saying, just an example. That was a 2. How much NaCl would I need? 0.075, right?
Yeah.
Okay. Right, because you would take the 0.15 divided by 2, multiply by 1, and that'd give you 0.075. But that's not the case. I just wanted to share that with you just to kind of realize how that was going to all go. So it's 0.15. So guess all we have to do now? Find the formula mass of NaCl, and that will allow us to calculate the mass of the solid. Because we already got the moles of it that we need. So then we would take this 0.15, so we don't really have to do the change in equilibrium there, because all we're doing is a comparison and how much we need of the other one. So then it would be 0.15 moles, and that would be NaCl, and then we multiply by its molar mass. So, anybody have sodium chloride memorized? 58.45 grams per mole. And then we get our answer. And so that's how you do a problem like that. So it'd be 8.77 grams. Okay? So really it is just stoichiometry. Once you get moles, it's no different than what we've already done. Once you find moles, then it's just mole relationships and stoichiometry, and that's all you have to do. Okay? So I got one more to share with you. We're going to do the one on the next page on 139. And I'm going to go ahead and write that one out for purposes of showing on the video. If you would, you guys don't have to write it out, but if you guys would write out just the formula equation and balance it, I need you to do that. So just go ahead and write out the formula equation and balance it. Okay, so that's the reaction. Is that what you guys have written out? Okay. So here's the deal. We're supposed to figure out when we have a solution, we want to calculate this mass. So we want to find out how many grams that we have of that. And so we have the ICE. So you guys have to find the moles of lead nitrate, and you guys got to find the moles of Na2SO4 in your solution. So find those two. And it's just like we did before. You've got the volume and the molarity of both solutions. So then find out how many moles you have of the total solution. That gives me the moles of PbNO3. So when I take 1.25 times 0.05 molarity, I get the moles of PbNO3. And so the moles of PbNO3 is 0.0625, is that right? Mm-hmm. 0.0625. Then I do the same with Na2SO4. I take 2 times 0.025, and I get an answer that's 0.05 moles. Okay, so this is a nice and easy one I gave you, or they came up. Which one's going to run out? Which one runs out? Na2SO4.
Yeah.
It runs out. So we may not be asked for the ending amount, but all I have to do is I'm going to take this and change. It's going to get rid of all the 0.05, and it's going to be 0 moles left over. Here, if I subtract 0.0, because it's a 1-to-1 ratio, 5, then I got 0.0125 left over. I'm probably not going to have to use that, but just in case, just to kind of show it there. So this starts out, these start out 0 at the beginning. So how much lead sulfate is going to be produced? Plus 0.05.
Yeah.
How much, if we had the sulfur, which we don't, how much NO3 is going to be made? Plus 0.10, right?
Oh yeah, because there's a 2.
Okay, because there's a 2 in front of it. But you just got to be careful of that when you do the, that you see the ratio, and this ratio down here has to be 1 to 1 to 1 to 2. So this here, I make 0.05 moles. Now all I have to do is multiply it by its weight, PbSO4. And PbSO4's weight is 303.3 grams per mole. So for every 0.05 moles of PbSO4, I have 1 mole of it is going to equal 303.3. And then I got my answer. My answer is 15.2 grams. That's how much is going to be made. In the past, we've done a lab. I don't know if I'll do it this year or not. But in the past, we did a lab where I gave you 2 solutions. You mixed them together. You would form a solid. Then theoretically, you'd figure out, this is theoretically, how much is made. And then you would go dry your solid and see how it compares. So I don't know if we'll do that or not, but we've done that in the past. So. I'm going to give you a couple of these problems to do, and then tomorrow you can come in and work on some of these problems. If you don't want to do homework tonight or whatever, it's not necessary, but if you want to get them done and kind of see how you're doing on them, I'll go ahead and give those to you. So do page 163C, and I have you do 61 and 62. You do not have to go all the way through and show the complete ionic and the net ionic. You just have to show the formula equation like we did on those 2. That's fine. And then you can set up the ICE and solve for those. So it'd be 61 and 62 on those 2 pages, on that page.